Here at VP.Start, we focus on creating solutions to modernize the grid. These solutions include the RPM grid system, LMS, and DRS system, which all support our DRC devices. Now, understanding how the electrical grid works can be quite complicated. So that's why here at VP.Start, we created a simulator to make it easier for you to understand. Let's go and have a look. Now, as we know, the power is generated at a power station, which is then transmitted through to a substation, which is then transmitted to a ring main unit. Now, these ring main units we've left here on our simulator. Here is one here, and this one is set forth for the outside line. So the power starts here, goes all the way around, and stops here. The second ring main unit for the inside line starts here and goes all the way around through here, and again, stops here. So what we're going to do now is we're going to find a problem. Let's come and have a look and see what a problem potentially could be. So there's two types of faults that we have. There's a permanent fault. Permanent fault is a severe weather event where the lines come down, or we have what's called a temporary fault. Now, a temporary fault could be something as simple as tree branches hitting the lines. In our case, we actually have this available. So here we go, here's our tree, and it's going to hit the line. Now, when this hits the line, there's going to be procedures and alerts that are going to be sent out. Let's have a look and see what happens. Tree hits the line, and the lights are flashing. Now, these lights up here is a fault indicator. A fault indicator, which sits on the line, comes on the top and hangs there. Now, what it does is, if there is a fault, a light will blink. Blink, blink, blink. As you can see, the light's blinking on here. So now we're going to go and have a look at our fault. Now, we know our fault is the tree that's hit the line, and the lights are flashing. When this happens, an alarm gets immediately sent to the RPM grid system for the operator, and also to the admin's mobile phone using our app. From here, we can see the overhead faults are flashing, the lights are flashing at the first point. We can see the same at the second point, but it's not happening at the third point. Therefore, we can deduce that the error is happening between this point and this point. Therefore, we need to isolate this power. So the first thing that we need to do is we need to open the switch here. We open it here. This allows for the power to keep going through and stops at this point. So now we need to open the DRC009, and then we need to come around here and close the DRC002. This allows the power to come through the grid. Now, we need to come around here and check. All of this, by the way, is being sent to the phone and to the RPM grid at every change, at every point. Now that we have isolated the issue, the teams need to go out to fix the debris or remove the branches. Once they are heading out to the location, it may be a distance of 1 kilometer, 10 kilometers, or 20 kilometers. Using our technology, you'll be able to use the geolocating tag that will identify exactly which closest area it is. Now, once the debris has been removed, at this point, because we've shared the power, this now needs to open at the DRC002. We need to come back around and close the DRC009. Therefore, we need to come to the DRC002 and close it so the electricity can now flow. So the electricity is now back on. Everything is working properly. By having DRC solutions installed to the grid, you can save time, you can save money, and most of all, the end users will have more confidence in their electrical provider, which is important for sustaining the grid, a smart grid for a smarter future.
VP.Start, innovation through technology.